Today, we're running a coding agent with a self-hosted LLM. This is OpenCode generating a game in JavaScript, and the whole thing is driven by the 7 billion parameter Qwen 2.5 coder served by vLLM and running on a GPU in Lambda Cloud. And because it's open weights and open source, we control the whole thing, from the model to the inference stack to the code it writes. We will be getting our GPUs from Lambda Cloud. It's pretty easy to set up. You just have to log in and provide your billing information and you're good to go. The coding agent will be OpenCode, which supports multiple providers. We'll be using the 7 billion parameters Qwen 2.5 coder, which is available on Hugging Face, and we'll be using vLLM for inference and for exposing an API that OpenCode will connect to. I have already signed up to Lambda and provided my billing information, and we can just launch an instance as so. As we can see, we have a long list to pick from, but some of them are unfortunately unavailable. Since we'll be running a smallish model, the 7 billion parameters, this A10 GPU will do. But if you want to run a bigger model, it's exactly the same steps. As long as the GPU or the cluster is big enough to run your model, you could just pick any other one. You choose the region. It's a layer on top of your Ubuntu. Confirm the firewall rules. By default, Lambda Cloud only allows port 22 for SSH, and everything else is closed. Make sure that our instance is not accessible from any other port. And then I have already provided an SSH key in a previous run with a public SSH key. If it's not the case, you just paste one so you can log in with the corresponding private key. And once we do that, we launch the instance. This is going to take a few minutes. And once the instance is ready, we'll get an IP address and we can SSH into it using the private key that corresponds to that public key. Our model weights are available on Hugging Face, which is basically the GitHub of machine learning. So you have models, weights, notebooks. The model is available here and we can actually download it directly. But in our case, we will be using vLLM, which will do that for us. So let's take a step back. Our model, in this case, Qwen 2.5 with the 7 billion parameters, is a set of weights. vLLM is a library that is going to download these weights, put them on the GPU, and then run computations on them. So we give it some input, basically some text, and then it's going to tokenize that and perform mathematical operations with the weights on the GPU and get a result back, which will be interpreted as tokens. So we give text in and we get text out. But that's only the inference part. We still need a way to access that model. We need an API, and thankfully vLLM offers that too. So it offers an OpenAI-compatible API. In addition to taking an input and doing inference using model weights and giving us an output, it also exposes an HTTP server that takes an HTTP request that has some input text in it, passes that input text to the model on the GPU, which will calculate the output and give us that output as an HTTP response. Our instance has been provisioned, and this is the IP address, and we can connect to it using SSH and the user Ubuntu, as we can see here. One command we can run to get information about the attached GPUs is NVIDIA SMI. As we can see here, we have 24 gigs. And there's information such as the temperature, so 31 degrees Celsius, the fan usage, the memory usage, if there is any process attached to it, and so on. So this means the GPU is configured. And we can even check the NVIDIA drivers and devices by looking at the dev file system path. So our vLLM library will use PyTorch, which uses CUDA, which will call this NVIDIA GPUs under the hood. The GPU itself is just a device attached to our virtual machine, and when we run the model, the weights will be loaded into the GPU and the calculations will take place there, and we'll get the result back into the CPU, and then we send it back through the network to the API endpoint that OpenCode will connect to. I specified the model here, and the name needs to match with what's hosted on Hugging Face. Then all we have to do is run this Docker command. it's going to download this vLLM OpenAI image, which contains all the vLLM library code and the server that will expose an OpenAI-compatible API. We provide some parameters such as the maximum model length, so basically a context length of 32K. We also enable auto tool choice, so our model will have the ability to call tools, because coding agents are nothing more than LLMs that have the ability to read files, edit files, look for files, fetch things from the web, so tools are essential. We are running a Docker container, and we specify this --GPUs option, which will basically copy all the drivers, all the NVIDIA drivers from the host, from this Ubuntu machine, onto the container. And in addition to that, it will give the container access to the GPU directly. In Docker, generally, everything is isolated. So we have the PID namespace, the network namespace, and so on. But with the GPUs, that's not really the case. The container has access to the host's GPU, to the host's GPU device and drivers directly. And as we can see here, the app has been downloaded and the container started. It is going to download the model weights from Hugging Face. So I have another tab open and we can see that the Docker container is running. I can SSH into the container and open a shell there. So let's do that. And as I said, if we look at the /dev NVIDIA, we're going to see the drivers. These were loaded because we specified the --GPU's Docker option. As we can see here, vLLM downloaded the checkpoints, the model weights from Hugging Face. And when we look inside this /root//.cache/Hugging Face hub models Qwen, and then we get all the information that relates to this model. And inside it, there is a snapshots directory, and it has all the relevant information. So these are the actual model weights. And as we can see here, the application startup is complete. Well, let's test it. Let's remember that when I started the container, I mapped the port 8000 on the container to the port 8000 on the host. So the API, which is exposed on port 8000, should be accessible from localhost within this Ubuntu machine. Now, as we said, vLLM exposes an OpenAI-compatible API. So a request that works with the OpenAI API should work here. Let's try. I'm defining the model, which is Qwen 2.5 coder 7b instruct, and I'm sending an HTTP request using curl to localhost 8000. As we said, the port is mapped from the container to the host, from the Docker container to the host on the v1 chat completions endpoint. And the message is, write an HTML page that explores a fun topic. We send a request and we should see that the model is generating tokens. And this is a synchronous request, so we need for the whole thing to finish before getting a result. And there you go. We have an HTML page that explores a fun topic. In practice, though, we don't want to wait for the whole thing to finish before starting to get a response. And that's what happens in practice in ChatGPT or in other coding agents. When you talk with it, you get a stream of responses. And this is actually a mode that's supported in the OpenAI API, where when you send the request, you can specify that you want streaming mode. And when that happens, we get output tokens as they are generated continuously instead of waiting for the whole thing to finish. And this is implemented using HTTP mechanism called server sent event. So usually in HTTP, you send a request and you get a response. With server sent events, you send a request and you continuously get responses from the server. We send the exact same request, but we add this stream equal true. And when that happens, we continuously get responses from the vLLM HTTP server as soon as the model outputs the tokens. And this is what OpenCode will use once we hook it up to our API. Okay, we are getting closer. We have an LLM running and it's exposing an OpenAI-compatible API. But the problem is it's running on a machine that only has port 22 open, and we don't really want to open port 8000 to the world. So what can we do? We can use SSH local port forwarding. What this does is that traffic from our local machine will be forwarded to the remote machine using the SSH tunnel. What we'll do here is that port 8000 on my local machine on my Mac will be forwarded to port 8000 on the remote machine whose IP is this. So whenever I access something on my local port 8000, it will be forwarded to the port 8000 on the Ubuntu machine with the GPU. And actually, that will be forwarded to the port 8000 within the container. So we got multiple layers, but we get it. We created an SSH tunnel from my Mac to the Ubuntu machine. And now I'm running on my Mac, but if I query localhost 8000, I will get the same response. What this means in practice is that we can configure our OpenCode to use localhost, the Mac's localhost, my computer's localhost, as the LLM's API server. OpenCode supports any OpenAI-compatible provider. And so here we can see in the example from the documentation that you can specify any base URL. As long as it's OpenAI compatible, it should work. In our case, since we did the local port forwarding, we can put localhost here and the Qwen model here. This OpenCode.json configuration can be specified on a project level, so within the root directory of your project, or on a system global level. Here is what my final result looks like. We specify the name of the provider, and this is random. Ceph works great, but you can use something else. We're pointing to localhost 8000 v1, and this is the name of the model. This needs to match the actual model because this will be added to the API endpoint. I also needed to set max tokens to 20,000, otherwise it kept erroring out. I think my understanding is that this puts a limit on the number of output tokens. So it's not the max for the whole context, but rather for just the output. And so since the input with the system prompt and my prompt, we already have like a 10K, we need to subtract that from the total. Any value that's very close to the limit of 32K, it just errors out. So now when we start OpenCode, when we do /models, we can look for, in my case, Ceph model, and I can see my custom provider. If you gave another name, you need to look for that. And we give it a try, and there you go. The model is surprisingly good. It kind of makes you wonder how can a 7 billion parameter model be capable of generating such code. As we saw with open weights and open source software such as OpenCode and vLLM, it is ridiculously easy to have your own coding agent with a self-hosted LLM. And given how sensitive code can be for certain industries or companies, or even any kind of information that's sent to LLM APIs really, we can see how self-hosting has its place. Anyway, I hope this has been informative. Let me know what you think in the comments. Till next time, bye-bye.